Hey everyone, welcome back to Sci-Fi Insights. Today I want to talk about NASA's recent success with the Double Asteroid Redirection Test, or DART mission. This was a huge milestone for planetary defense against dangerous asteroids, so let's break it down. On September 26, 2022, the DART spacecraft intentionally crashed into the asteroid Dimorphos at over 6 kilometers per second. This impact changed the asteroid's orbit around its larger companion Didymos by a whopping 32 minutes. Much more than the minimum success criteria of 73 seconds. This proves that kinetic impactors can be an effective way to deflect potentially hazardous asteroids. By ramming into the asteroid at high speeds, we can change its trajectory enough to miss colliding with Earth. Let's talk briefly about how this works. The kinetic impactor technique transfers momentum from the spacecraft to the asteroid. The mass and speed of the impactor determine how much the asteroid's path is altered. In the case of DART, its 544 kilograms mass and 6.6 kilometers per s speed imparted around 10,000 newton-seconds of momentum to the 10 million kilograms Dimorphos. This caused the asteroid's orbit to change by 32 minutes, avoiding a potential impact. So what can we learn from the success of DART? First, it shows kinetic impactors are a viable planetary defense strategy. Second, it gives us data to determine how much momentum is needed to deflect different-sized asteroids. And third, the impact created a visible dust cloud that will help study the results. DART paves the way for new asteroid deflection missions. The upcoming Hera probe, launching in 2024, will study Dimorphos and the DART crash site in detail. This will further improve our asteroid deflection models. Down the road, we will need a robust planetary defense plan incorporating different techniques. DART and Hera establish an important first line of defense, using kinetic impactors to deflect hazardous objects. It's an exciting time for planetary defense. DART shows we have viable strategies to protect our planet if a dangerous asteroid is discovered. Let's shift now to talk more about the implications. What does the success of DART mean for the future of humanity and Earth? First, it means we've taken a major step in controlling our destiny. Life on Earth has been at the mercy of asteroid impacts for billions of years. Now we finally have the technology to prevent catastrophic collisions. Second, as we become an interplanetary civilization, we will need the capability to precisely redirect objects through space. DART demonstrates expertise in precision orbital maneuvering that will assist future space missions. And third, this gives us some protection against potential unknown asteroid threats. DART shows we can rapidly develop missions to deflect newly spotted space rocks on a collision course with Earth. Of course, there are still challenges ahead. We need continued funding and support for robust planetary defense infrastructure. More research is required to refine deflection techniques and strategies, and we must expand our efforts to map asteroid populations and orbits. But DART is a tremendous start, proving we can alter the paths of asteroids and reduce the risk to our planet. This gives me hope that together we can overcome the dangers lurking in our solar system and build a bright future among the stars. All right, everyone. That wraps up today's episode on the groundbreaking DART asteroid deflection test. Let me know your thoughts in the comments below. And don't forget to like and subscribe for more science and futurism content. See you next time.